Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give you two more examples related to the idea of limits. So given the following graph, can you guess what is the limiting value of our function here when x approaches 4? So that's the first question. The second question in this example is asking you to explain why the graph is a straight line, or in other words, explain how the graph can be sketched, how the function can be sketched, and why at the end of it, the graph is just simply a straight line. But for this second question here, we will come back again in the next video. So in this particular video, we're just going to do this question here, the first one, and another example in the next slide. Okay, so if you look at the graph given here, you see that x approaches 4, which means the point of interest is at this one. So this is x equals to 4, and x approaches 4 can come either in the in this direction, or it can also comes from the left direction. Okay, so this is x, let us be specific, and this is fx. So when x approaches 4 from the right direction, you will see that the value of fx is going downwards, and it will approach this value here, which is equal to 2. Okay, and similarly, if x approaches 4 from the left direction, therefore the value of fx is going upwards, and it will come and be very close to this value here, which is equal to 2. So therefore, what we can do is we can write our answer as the limiting value for our function, which is x squared minus 6x plus 8 over x minus 4, when x approaches 4 is going to be equal to 2. Now, I hope you can see that if you substitute x equals to 4 into our function, then you will see that the function will be undefined. Yep. So when x is equal to 4, f4 is going to be 4 squared minus 6 times 4 plus 8 over 4 minus 4. And that becomes undefined because the denominator here is 0. So therefore, we say that f4 is undefined. Even though it is undefined, but the limit still exists, and this is obviously the case which you have seen in the previous video, which is the third case that we've discussed here, where basically we're saying that the limit of our function when x approaches a is a number L, but if you substitute a into the function, you won't be able to get the result, because at this point it is undefined. Okay, so this is the case where if you substitute a into the function, it becomes undefined. Okay, right, so there we go. That's the simple example, just to give more understanding to the definition of limit, which you have seen in the previous video. Yep. Okay, let's move on to the next example here. So in this example, you are asked to guess the value of this function when t approaches 0. Okay, so I hope you can see that if you substitute t equals to 0 into the function, so f0 here is going to be 0 squared, which is 0, plus 9 minus 3. This is going to be equal to 0. And therefore, in this circumstance, t equals to 0 will lead to f0 being undefined. So this is undefined. But again, it doesn't matter, because in the process of finding the limit of a function, we never consider t equals to 0. We are just focusing on t approaches 0. We are just focusing on t approaches 0, or t gets closer and closer to 0, but not exactly at t equals to 0. Yep. So when you have t equals to 0 as your point of interest, therefore t can approach this value here from either the right direction or the left direction. So from the right direction, we will consider the value of t being greater than 0, whereas from the left direction here, we will consider the values of t being less than 0. Okay, so normally in the tables which I have presented before, we will consider two different tables to denote two different way of approaching either the left side or the right side. But however, in this table we are combining those values together, plus and minus the value of t, because at the end the results that you get is going to be the same due to the fact that we have t squared in this function. Okay, so as an example, if you consider t equals to -1, the value of our function here is going to be equal to -1 squared is 1 plus 9. This is a square root of 10 minus 3, and over here we have -1 squared, which is equal to 1. Okay, so this results in the value of 0.16228. Okay, so now this is the considering the value of t being less than 0. Okay, t is equal to -1. So if you consider the value of t greater than 0, and if let's say we take the value of 1, okay, so therefore our function here is going to be to yield the same result, because 1 squared is equals to 1 plus 9, so minus 3, so 1 squared is 1. So you will get the same result, which is given by this one here. Alright, and therefore to save the space, we're just going to combine the values of positive and negative into the same space here. So positive, negative 1 will give you the same result as what I have demonstrated over here. So in this table, I'm just considering the values of t that gets very close and even close to 0. Okay, so the values here gets closer and closer to 0. And I believe you can complete this whole table by yourself. So I'm just giving you some results over here for you to compare, and then you can go on and try to complete this whole table and finally guess what's the value of this function when t approaches 0. And this is just an example to illustrate to you what a tedious process that you have to do. And you will appreciate that later on in this chapter 2, you will be seeing some of the rules or the limit, the laws of the limit, where you can actually use the laws to help you find the answer much quicker rather than doing all this tedious process. Alright, I think that's all for now. Thank you very much for watching.